So today we'll have some coding exercises at the beginning, not really an exercise, it's a coding demonstration. This will be very helpful for the first assignment. So if you go through this program, if you go through this coding exercise, you should be able to solve most of the first assignment. Right? This was not done typically in the previous year's run of the course, but we are doing it for the first time to help you get started with some of the functionalities and how to go about writing such programs. Can you please stop your discussions? We are figuring out how to increase the volume, so till that time please. So this was one question which you had to do in your prerequisite test, and I think most of you have done it correctly, which is to add two vectors. So firstly, the simple way to represent a vector in Python is through a list. We have created a list A and a list B. We can use this notation which is known as list comprehension, and zip, which will create two iterators and you then go over them and you sum them up. On the other hand, if you use something like numpy.array, you could have simply used numpy array A plus numpy array B. Most of you had got this correct. Why would we use the numpy array version as opposed to the list version? Anyone? Numpy support broadcasting, that's one reason. Okay, what could be some other reasons to choose the numpy method? It is definitely faster. Why is it faster? Because the inner routines, the loops are not in Python, they are in a compiled language. What else? Why might you use Python over, why might you use numpy over Python list? Sorry? Less chances of mistakes because you are writing lesser code, the code is more clear, succinct, and once you've done that, you can write it more, it's more closer to the math that you write. So all of you have done this correctly, but one thing which I saw missing in your prerequisite test was that you didn't really compare whether the answers you're getting from both the methods were correct or not. Right? So that's always important to do while you compare the timings between the two methods of addition of two lists or two arrays, but it's good to also compare whether the answers you're getting are correct or not. A simple method to do that is in NumPy called all close, which checks whether two vectors, two matrices are all close within a certain tolerance or not. Why don't we have a method all equals? Why do we have an all close method? We're dealing with floating point numbers. The comparison you're looking with is within a certain tolerance, not exact comparisons. You're not doing 3.00001 equal to 3.0001 or not, right? This is a classic example which we study in programming the first course. So most of you have done the timing comparison something like this. You have created a large array and a large list, and then you have done a loop over, let's say, 1,000 times, and you have done the addition of this through both these methods and then figured out the mean and the standard deviation over these methods, right, over these calls. Why does it make sense to have a loop to do the measurement and not just once? Sorry? Okay. Any other reason you might be using a for loop? So I'm running this method of finding the sum 1,000 times. Why 1,000? Why not just once? It may be insignificant, but if the order is maintained, if it takes, let's say if it's insignificant, but each of the 1,000 run, it takes the exact same time. So then why does it matter? It might not be taking the exact same time. There might be other background processes. There could be a lot of non-determinism which comes into play. But if you aggregate these statistics over a large number of samples and over a large number of experiments, you will get reasonably good results. So if I ran this method once and it showed me that the list sum method is quicker than NumPy sum, you should not take that result immediately into consideration. If this happens over 1,000 runs, then you should be concerned. You should take that into consideration. And once I ran this here, I saw that my NumPy addition method is orders of magnitude quicker, which is expected. We did the same for the vector product, which is pairwise, or just the dot product of two vectors. Again, we do the all close. Some of you had used the timeit module. but I am showing, but because all of you didn't use, I wanted to show how to use time it module. You given the, it's a cell magic in Jupyter notebook. So you can read about cell magics. There are quite a few of them. If you look at cell magics in Jupyter, you might have used some of them, but not all. So CD is an interesting one, which I've used earlier. Some of you have also done pip install, right? When you were trying to install JAX and other things. Some of you wrote it with a exclamation mark pip install. Some of you just wrote pip install. The recommended one is %, which is a cell magic. Right? You can read about this more on Stack Overflow, why this specific one is recommended. There are some other very cool magic commands which exist. History, to give you the history of all the types you have, all the lines you have typed, and so on. So time it module, now if you notice, it is giving me in a very nice representation the time taken in terms of the mean plus minus standard deviation over 1000 loops, and the other one over 100,000 loops. But if you notice, when we were writing the loops, we typically wrote, let's run both the methods the same number of times. Right? Why do you think the time it module ran it for a different number of times? Is it a fair comparison? But it's a production level code, so there must be some good reason behind this. The time taken by the second function is significantly less. Perhaps there is a global timeout that let's not run it beyond 5 seconds, 4 seconds. In that 5 or 4 seconds, the number of calls that you're able to make is what you make. Right? Something like that is perhaps pre-decided. That is why the second one runs for 100,000 times, the first one runs only for 1,000 times, and you can see significantly there's an order of magnitude of difference, orders of magnitude of difference between them. The other reason which I mentioned was code clarity. So imagine if you have to write A into A star B for A comma B and zip list A comma list B. So this is a list comprehension way of writing. If you instead have to write it via for loops, it will become significantly bigger. But in contrast, if you just write numpy array A into numpy array B, right, it's much more succinct, it's easier to understand, interpret what is going on. Did anyone use the symbol method, symbol operator in this assignment? So the numpy product that you get is some list. Okay, not. Okay, we get some number. What is this number? This is dot product, right? Or the matrix product if you look at it that way. Another thing which you will very commonly face in machine learning is dealing with CSV or similar like data. And thus far, let's say that we knew only NumPy. Right? So I will show you the same data set which you had been looking in the ML course, which was the tennis data set. So this is stored in a CSV format. What does CSV stand for? Comma separated values. You have values which are separated by commas. Right? So NumPy and by the way, this is a method. This is the way you can call some Unix commands directly from the Jupyter notebook. Head is a Unix command to show the first few lines of a file. So there is a method in NumPy called gen from txt. This is used to read a CSV file, and I have to specify the delimiter, which is because it's comma separated values. In this case, the delimiter is comma. But if I run this command, I get on lance. What is going on? The data that you're trying to read is not numeric in nature. So if you try to read using the defaults, you'll get an error. What might you need to change? So so for such things, you should always, let's say, go to just write the function name, just put a question mark. It will give you the default, it will give you the documentation, and just look at the signature. So it has a file name, data type equal to float. So the default is float, but ours is not float, it's string. It has comments, delimiter, skip header. I think the delimiter is perhaps by default to comma, I don't know. And it has various other things like skip header equal to 0, skip footer equal to 0 or not. So it maybe suggests that we should be looking at the d type argument, and that's what I've done. I've given d type equal to string. If I read it this way, now my data looks like this, right? It seems to be in a much, like it's the data which we had. Again, if you go back to the documentation, you may see that there is something known as skip header equal to 0. Right? What do you think that will do if I give that argument? Skip header equal to 1, and if I print out data, can you see that the header row has been removed? Right? In this case, perhaps you didn't need the header row, you have to process it in a separate way. But for now, I will keep the header row, I will delete this. Now, one of the things which you have to do a lot in machine learning and data sciences is to do some exploratory data analysis, or to figure out, to understand your data. Right? So if I give you this question, that what is the outlook on D11? Of course, for you it's quite easy now to see on the data, because you can see this entire record and you will say that it's sunny. Right? But let's say if you had to write a Numpy code to do this, how would you do that? So firstly, you may want to see the shape of data is 15,6, 15 rows, 6 columns. We had 14 examples and the first one is the header. How would I find out the outlook corresponding to D11? Okay, excellent. So Priyanshi says that you'll have to first notice that the outlook is the second column, but if you start from 0 indexing, it's the 0th and the first column, and then you have to figure out the row number, and then you have to do a joint lookup. Right? So what you might end up doing is first find out the index, where if you look at all the rows and the first column, this is the syntax. So I am hoping that you have got a chance to look through the Python for Data Science handbook and the similar prerequisite documents given. So this syntax is very commonly used. Data colon comma 0 means, colon means that you're accessing all the rows, and 0 means you're looking at the first column. So you're just looking at the day and D1 through D14 column. You check which of them is D11, and then there are some arguments you need to give to ensure that the index comes in as a integer. So the index where data of all rows and 0th column is D11 is 11th, and then I can check data of IDX. It gives me a record, gives me a row having D11 sunny, mild, normal, wind, yes, etc. And then I have to look up the first attribute in this, right? 0th and first attribute in it. So if I do data of IDX of 1, I get the answer is sunny. So do you notice that it's a very convolved way of getting at this answer? Why do you think this was so complicated? Yeah. So we have to store the mapping, or we have to know the mapping between the column names and the column values. I mean the column indices from 0 to 6, 0 to 5, and the actual column names. Similarly for the rows also, we have to store that. Right? So this is where something like Pandas comes in very handy. So therefore in machine learning, you'll commonly see people shifting between Numpy and Pandas and so on and so forth. So people often do some of the data pre-processing in Pandas, convert it into a matrix-like format, and after that it's just Numpy. So I have now read the same data set, and because all of you have done the prerequisite test, you would already know what a data frame looks like. I see that it has 14 columns, 14 rows 0 through 13, and it has the header automatically figured out, right? Day, outlook, temperature, humidity, windy, play, and the other good thing is it's displayed very nicely, which just aids the visual understanding. What if I didn't want to store the 0 through 13 as a separate index? Again, I'll have to understand, I have to go through the documentation of pd.read CSV and maybe understand that there is something to store or not store the index, so specify in the index. So if I do pd.read CSV question mark, it has separator, delimiter, header, names, index columns. So index column is an option, and if I were to instead do index column equal to 0, and now look at my df, do you see a difference? Previously my index was from 0 through 13, it was just the sequence of numbers. Now my index has become the day, right? So these are different ways in which you can solve the problems. Again, I don't want you to focus on the specifics of the exact methods I'm showing, but rather I want you to focus on the process I'm following in order to understand what we may need to do. So I'll go back to the previous one, I'll just delete this column, I'll show you the df. Now if I have to answer this question as to what is the outlook when the day is D11, my syntax is significantly easier. I look at df of day equal to D11, right? And then I write df and then square brackets of this and then a square bracket on outlook. There are quite a few things happening here. Can someone help parse this for me? What is going on? So whenever you ask such a question, it's usually useful to start from the innermost place, innermost brackets. df of day equal to D11. So you can always just copy this, run it in a new cell. I get a series of trues or false, right? So this is known as a binary selection or a selection mask. In this case, the selection mask is either true or false. And once you apply this mask over the df, so it will say that wherever it's true, I will only give you those values. It's true at this location, right? And if I then do df of day equal to 11, now I get a data frame which consists of all the records, all the columns, but I then wanted only the specific attribute, which is the outlook one, right? So therefore then I put the outlook. This is the way to access a specific column in Pandas. Again, not going into all the details, but if you have looked at the recent API, you have a much cleaner way to write df.query, the column name equal to D11, and then you look at the attribute that you want to print. I would always recommend use something like this. It's easier. You can also look at df shape, which tells you the rows and the number of columns. So this is where now we come on to the questions which are extremely pertinent to your first assignment. Specifically, we'll be looking at calculations for entropy, etc. We're looking at 3 or 4 different methods to do that. You can always write for loops and get the correct answers, but that will be prone to making mistakes as well as slow. Okay, given this data set, how many times do we play or not play tennis? This is the data frame. Why don't you think of this query that you may need to write in your notebook and just write it in your notebook? I want you to figure out the number of times we play or we don't play. Thus that. The answer is 9 and 5. df.query is another subset df. It's another df. It's a df. It's another df. Okay, are we done? Can someone tell me their solution? Okay, I'll have to pick people now. Okay, someone from the third row. Yes, third row. So that's the magic of asking questions, that whenever you ask the questions, people will start looking at each other and not at the instructor. Yes, third row. I'm sure you know the answer. You've got some answer. We can use dot count. So there is no as such method dot count. There is a method for unique, and there is a method called value count. But you could have once put also, you could have put a for loop also. So you could have written this as df. Okay, let's do an inefficient method of solving this, and then I'll show you the efficient one. So df of play equal to yes, right? We get this array. We can do a sum of it. Sum of this gives you zeros and ones basically, right? So so false will not contribute to it. It gives me 9, and I could have similarly done df of play equal to no dot sum. You'll get 9, 5. But often you'll want to generalize this because I've hard coded the values here. So you may first want to find unique play options, whether you play or not, I don't know. So that is df of play dot unique. So this will give you an array of no's and yes. Now you can iterate over this array and print something like for option in unique play options, print option df play equal to option dot sum, which is what I had previously written. So no's is 5, yes is 9, but importantly you have to first find out all the unique elements, then you have to do a for loop over it. Both of these operations you have done in Python and Pandas. You have not done them using inner compiled loops or using faster inbuilt methods. Therefore this will be slightly slow, but you'll get the same answer. I actually recommend first time you always try using this way so that you understand the data structure better. But there is a single line of code which is much more efficient. Was that an option like that? I didn't know that. Good. So here. So let's create a series equal to df dot play. So this is our series, and Jadav says that there is an option, an argument in unique. I didn't know about that. It gives us return unique values. Yeah, it doesn't take an argument. So perhaps what he has done is he's maybe looked at the numpy dot unique argument or set of arguments. But it's always good to clarify just to quickly check. So value counts, it works well and it gives you the answers like this. Will it work for all kinds of data? In our case currently the data was categorical or discrete. Will it work when the data is real? Exercise for you. You can try this out later and see what you get. How many of you have done SQL, structured query language? Is that the full form? Structured query language? Okay. Okay, so those of you who have done structured query language or SQLs or databases, you might have very commonly used a term called group by, a specific term called group by. So we can get the same answer using something known as group by. It's an overkill for this question, but it will be very useful for your further entropy questions, etc. for the assignment. We can group by the play attribute and find out the sizes that we have. So if I do df.group by a play and dot size, I get this answer. You can also just do df.group by play. Right, so this gives you some group by object. Right, so let me show you what that is. Let me just call that GBY. So GBY, let's say I don't know what all it contains. So typically this is what I do when I am trying to learn an API. I'll press dot and then press, I'll actually turn off Copilot firstly so that it just doesn't give me all the suggestions. I will then press tab and see what the different arguments it gives. So one of the attribute it stores is called groups. Now does this help you understand what is happening? So I've got the different groups corresponding to this attribute play. What do you think these entries are? These are the indices, right? Could I have now used these to also solve the problem at hand? I could have just done gby equal to df.group by play, gby.groups. It gives me a dictionary, and then I just need key comma len of v for kv in dot items, right? So this is a dictionary comprehension. Some of you might have used, some of you might not have used. This is basically, think of it as a for loop I wrote over that, and from that I just put the key and the value and put them in a new dictionary. So it's a succinct way to write. Group by is very useful in such things. By the way, keep getting the questions. If you have any questions, please let me know. The other very nice utility is cross tab. Has anyone used cross tabulation? Anyone heard of pivot tables? In Excel, you might have heard of things like pivot tables. This you can think of as a simplified version of that for very specific kinds of pivot table operations you want to do. So you do a cross tabulation where the index becomes play and the columns are the count. So you do some kind of an aggregation, which is also what the group by operations give you. So for group by, I would highly recommend you go through Pandas documentation, group by and Pandas if you search for. Not the default documentation, but they have this tutorial user guide on group by, which contains 3 paradigms: split, apply, combine. So it's a usual process. You split the data into groups. In our case, we have split the data into the group of play yes or play no, 2 groups. We apply a function. In our case, that function was just the count, the number of times we played or not played. And then sometimes you do some combination, which we didn't need for a current problem at hand. So cross tabulation, you need to specify the index, the column, sometimes you need to specify the rows, and it just creates a beautiful looking simple table. Okay, the next question is just a follow up of this. We need to find the distribution of any given attribute. By distribution, I mean just the relative counts of the different values which the attribute can take. We have already solved this problem, so I'll just write a simple function around that. It's df of attribute.value counts. So if I do distribution on the outlook, I get sunny 5, rain 5, overcast 4. Now think back about the decision tree lecture. Where would you use this function? Distribution of df comma the attribute name. Not for entropy. I mean, the attribute here is the input attribute. I'm not looking at the output attribute. If the attribute is the output attribute play, I would be using that for entropy calculation. Right? But this is an input attribute. Where would we use this function? There are only 2 things in decision tree algorithm, right? Information gain, right? Information gain, if you remember, you had to look at the weighted entropies of the subsets. So now you look at the number of entries which sunny takes, rain takes, overcast takes. So if you want, we can just go back to that specific slide and right. So we had the specific slide. We need to know the number of entries for each of the value of outlook, and that's what we have obtained using this piece of code. Right? We just have got the distribution of a discrete attribute, I mean an attribute which takes discrete values like this. This distribution is actually a Pandas series. A Pandas series you can think of as an object which has an index and a value and a array. Right? So this is how it's slightly different from a NumPy array. So let's see. Let me store this somewhere. I'll call it SER for series. I can just print the series. I can show you, confirm that the type of SER is pandas.series. So series, so think of a data frame containing multiple series, each of which have a common index. That's how we think of them. And the relationship between a series and a NumPy value and a NumPy array is this. So series.values gives you the values in NumPy array, which contains the values, and correspondingly you also have series.index. In this case, it's sunny, rain, overcast. It's a dictionary in a enumerated form. Yes, you can think of a simple dictionary as a series and a complicated dictionary with multi levels as a data frame. And this is one of the things which I use very commonly in machine learning. Specifically, when I'm trying to compute the results, figuring out the best hyperparameter for a certain algorithm, etc. It will get used a lot. Other questions? Okay, what if data was continuous? What is the question there? Yes. If the data is continuous, then if I tell you that, then I've solved the entire assignment for you. I have actually solved that entire assignment for you if you go through some of the other notebooks mentioned in the course website. We had looked at the specific case where we were finding the mean squared error. So that's what you need to do. I can point you out to the exact notebook, but I think that will make it too easy. Okay. So we need to now also find the entropy of a target variable. Remember that the entropy is always calculated with respect to the target variable. In our case, it's play or not play. So target attribute is play. I call distribution of the target is distribution of df comma target attribute. So my distribution the target variable is 9 yeses and 5 nos. What was the formula for entropy? Summation minus p into log p. The two values that you're taking is yes and no, but these are not probabilities, these are counts. So therefore you need a way to calculate the probabilities. How will you do that? 9 over 14 and 5 over 14. So you can sum up these values and divide this by the sum, this series by the sum. So distribution target is this series. You divide this by the distribution target dot sum. Sum will be 14. Do 9 over 14, 5 over 14, you will get this series. Right? Or you could have used df of play dot value counts normalize equal to true. When you are finding out the value counts itself, you could have said normalize equal to true, you will get the values as 0.64, 0.35. Right? So I'm just showing a bunch of such functionalities which exist. You could always write for loops and figure out this on your own. Okay, now given these two numbers, how do you think we should calculate the entropy? It's a pandas.series, you can iterate over it. Take the log base 2 of this, multiply it with this, and then, when that's the formula, how would you implement that in code? For loop, because you need to look at each and every value. In this case, it's only 2, but sometimes you can have 3, 5, 10, whatever number of values. So you can initialize, this is the C-like method of finding out entropy. Initialize entropy to be 0. For value comma p, normalize this target dot items. So you are also able to iterate over a pandas series like a dictionary. And then e equal to e minus p into numpy dot log base 2 p plus 1e minus 6. 1e minus 6 I specifically added to avoid the log 0 problem. Right? Or I could have used the x log y import from SciPy, or I could have done nan to num. Some of those things I've already shown you. And if I do this, my entropy turns out to be 0.94, which exactly matches what we had shown in the class slides. Okay. So generally in machine learning, you want to avoid these for loops. So for such specific calculations, Pandas again provides a very nice functionality called apply. You have a Pandas series or a data frame, you call that apply method to it, and you give the function which you need to apply on each of the row, the specific row. That function is, if it takes x as an argument, it does minus x into numpy.log base 2 x. Right. So I do normalized. Let me actually first the show without applying the dot sum. So if I do normalize this dot target dot apply lambda x minus x into numpy dot log base 2 x plus 1 e minus 6 for each of the value, for 0.64 it does minus 0.64 into log base 2 0.64, the value you get is 0.50, and similarly you get the value 0.53, and then you can do a sum over it to get the value as 0.94. So this way you have avoided a for loop, you have lesser chances of making a mistake, and the functional transform is very explicitly clear here. Okay, now we need to go on to information gain and finding out the sum of the entropies, weighted sum of the entropies, right. So in which case we can again come back to our friend cross tab. So now does this function look very useful to you immediately? We call cross tab, we say that the index is is outlook and my columns are play, right. So play takes two values, for both no and yes it figures out the counts from the table, from the data frame. And now looking at this, can you tell me the relative entropy? What would you need to do? So one thing you may need to do is to firstly just take the transpose of this matrix to make calculations easier. So I do just take the transpose of it, and you notice that the rows and columns are interchanged. Now for each of the column, can you find out the proportions of no's and yeses? How? By normalizing. So I just call normalize equal to by columns in the cross tab. Now I get 0, 1, 0.4, 0.6, 0.6, 0.4. Right. Now do you know that for overcast the entropy would be 0? Right. Can you naturally just see that? With rain it will be minus p log p over 0.4 and 0.6, and this over 0.6 and 0.4, both of which should be same values. Or I could have created a table like this using group by. Right. Can you think of what that group by statement could have been? Can you think for a minute and write in a notebook to get a table looking somewhat comparable to this? It's not very trivial until unless you have seen this before. Okay, let me show you first output. I call the group by on multiple attributes. Probably you not thought of that because of the way I had previously shown you how to use group by. If I do div.group by on both the attributes, play and outlook, and you look at the size of them, I get, if I play no, then I can have outlooks of rain and sun. If I play yes, I can have the outlook of overcast, rain and sunny. Right. So this is using something known as a hierarchical index. If I look at df.group by the above line and I look at the index of it, it's a hierarchical index, means it has, it's not just one value, it's two values, or it's a tuple. So it's the values that are taken are no rain, no sunny, yes overcast, yes rain, yes sunny. I can call a method called unstack on the outlook attribute, so it then pushes it to the columns. Right? You had two values in the index, you unstack it and you push one of them to the columns. Again, I don't expect you to remember all of these things. These are just there to make your program easier, to make it quicker and serve as some reference so that you can search these methods on your own. But we get a nan. So we need to fill that nan with a 0. So I do a fill na 0. And I get 0, 2, 0, 4, 3, 0. After this, I can again apply the same normalization as I had done before. And I can also on this data frame apply the same minus x into log base 2x. I also additionally give an argument axis equal to 0. Homework for you to figure out why I have given this and what could be the other option, axis equal to 0 or 1. And now you see these numbers. For overcast, I see 0, 0, rain, I see 0.5, 0.4, and 0.4 and 0.52. Right. Do I just sum up these numbers to get the entropies? We have to weight them. Weight them by the number of samples we had for each of overcast, rainy, and sunny. The number of samples we had for each of them. So firstly, I just let's just sum them up, and then I can do the weighting. If I do the summing, I get 0.97.97, and my weights are 0.3, 0.3, and 0.28, which was just the fraction. I need to now multiply them and then take an overall sum, and I get 0.7. Right now, you can calculate the information gain, which will turn out to be roughly 0.246, which is what we showed. Right, so this turns out to be the number 0.6935. So 0.94 minus 0.347 minus 0.347. Okay, there's perhaps some small difference. No, that's the weight. So if we do the weighting, I think we'll get number to be 0.246. Yeah, we'll get that number. So this should help you with the, at least on the question on the decision trees when you have discrete input, discrete output. When you have discrete input, real output, we have already seen, like we've seen all the 4 cases. This is one of the cases where I think it's slightly harder because of the discrete values. For the continuous attributes, the functions, mean squared error, etc., I think we find them easy. Any questions on this? Okay. So I'll also very quickly walk through how to create a class for a specific kind of tree and then for a decision tree. Again, this is, I'm expecting that you know all of these things, but I'm giving you just some good structure which makes it easy to visualize classes. I'll be using something known as Graphviz to beautifully visualize these tree-like structures. So I'll first show you the end product. This is the tree I want to create. I have a root. I have a child 1 and a child 2, and child 3 is a child of child 2. So I end up defining a class tree node where I have to specify a name, which is the name of that specific node, the value which it takes, the children, which is a list. So each node can have a bunch of list of childrens, and this shape specific thing is just for visualization I'm doing. The add child method is very simple. You have to give a child node which has to be also a type of tree node. So it's good to verify that. Cell.general.append child node. The visualization is using some code in Graphviz. I've also provided 2 kinds of visualization. One is display using text, the other is display using Graphviz. So using text, you can also see very quickly see this functionality. Right? So root, the value stored is none in all of them at this point of time. Now going from this regular tree to decision tree, there will be only a few differences that we'll have. So first, I'll have the feature which appears. So let me first again show you. You will have the feature, it could be the outlook, right? So this is when the features are in the continuous space. If the features are on the discrete space, you will not have less than equal to, you just have, let's say, outlook. And the branches will have wind, the branches will have, let's say, sunny or the other values which the attribute took. But this is the case with the input features take on real values. So we always have the decisions as feature name less than equal to something and then true or false. So this is how you can create a tree-like structure. Finally, we have the decision or the value which is stored. So I've just tried to model this on the sklearn interface, the visualization which we get from that. If you notice the call method, So this is another software engineering skill or tip I'll share with you that's often useful to first write the user level code of how the tray should have been created or how the API should be called before you create the actual API or you create the actual method which is being called, right. So does this method make sense to you? You have a root node with the name of a feature, the threshold and decision. You have a left child, a right child, all of them are decision tree nodes. Root.left equal to left child, root.left equal to right child, and so on and so forth you can create. So then the only thing you have to care about is to how to go ahead and write this class method, right. Again, might look very scary. Some of this is just because of the displaying in Graphviz. So you have to take care of certain things where certain things are none and all. So you can use this also as a starter code for your assignments for creating decision trees from scratch. Any questions? Okay, so we'll go back now to the classroom mode and we'll study